Welcome to Sankalp Learning Solutions. How are you all? I hope you all are doing good, right? Okay. Today you have English medium session. Today we are going to discuss some concept which is related to the topic magnetic effect of electric current. Okay. See students, in our last sessions we have already learned that electricity chapter, isn't it? Yes, in that chapter, we studied about electricity detailing. Okay, just analyze those things once, and next we'll go to this chapter, that is magnetic effect of electric current. See, in electricity chapter, we studied about that conductors and how the current is generated in conductors and all, right? See, consider this is your conductor. Okay, consider this is conductor which is connected in battery. Okay, this is connected in battery and other instruments are also there in the circuit. Okay, just imagine. See, this is conductor. It contains some electrons, right? Which is considered as charge carriers, right? Just remember that electricity chapter 1, students. Okay, it's very helpful to study this chapter. That's why I'm saying. Okay, see, when the conductor is connected in this battery, see, this is the positive terminal of the battery and this is the negative terminal of the battery. We always show the conventional current direction from positive to negative terminal of the battery. Yes, we know that, right? Okay. See, what happens when the current start flowing through the conductor, that time we generally consider, or here it generates or it produces mainly three types of effects. Okay, mainly three types of effects. What are those? What are those effects, students? Some effects you already learned in electricity chapter, right? What are those? Firstly, we learned here, or this circuit generates that heating effect, right? Heating effect, yes. What is heating effect, students? What is heating effect? Yes, we know that because we already learned this in our electricity lesson, right? Okay, heating effect is nothing but when the current flows through the circuit. At that time, what happens? We know that we use some appliances or some components in our home, which is works under the principle of heating effect, right? For example, heaters or electric bulbs, all are produces the heating effect when the continuous current is flows in the circuit. What happens? Sometimes it generates heat, right? For example, in your home, you just continuously flow the or on the switch of bulb. What happens after sometimes? Just touch that bulb. What do you feel? Yes, you feel heat, right? It becomes hot. Why? Because due to this electricity, here heating effect is generated, right? How this heating effect is generated in the circuit? Yes, this is also we studied in electricity topic, right? How this heating effect is generated? What is the cause? We know that conductors contain some charge carriers, that is nothing but electrons, right? Okay, when the current starts flowing in the circuit, what happens? Here the collision takes place between the electrons. See, when the current is start flowing in the circuit, here the electrons get collide each other. Due to that collision, heat is liberated or heat is generated, what we call. Okay, that is called heating effect. So this is the first effect which generates, this circuit generates. Okay, when the current flows through the circuit, we can see mainly three types of effects. First one is heating effect. Yes. Second one is, what is the second type of effect? That is chemical effect, right? That is chemical effect. What is chemical effect, students? What is chemical effect? I hope you all are very well known about this chemical effect, right? Because it comes in your chemistry related topics, right? What is chemical effect, how it is generated and all. We know that here this chemical effect is also generated by electric effects, okay? Electric current. Due to electric current, it generates chemical effect. How? Generally here we consider that liquid conductors, right? Liquid conductor. This chemical effect is we can easily see in liquid conductors. What is conductors? Conductors is nothing but it is the substance which allows the current to flow through them, right? It allows the current to flow through them. So here we consider liquid conductors. We can easily see this chemical effect. When the current flows through this liquid conductor, what happens? Some chemical reactions takes place. That is called chemical effect. Okay. What is the example? For example, consider that H2O. This is very, very stable compound. We know that, right? Okay. When the chemical effect takes place due to the electricity, what happens? This H2O breaks into H2 plus O2 ions, right? It breaks into H2, that is nothing but hydrogen and oxygen ions. So this is due to the mainly due to the chemical effect. How this chemical effect is generated? It is generated due to the electricity, right? Okay, this is the second type effects. What it is generated in electric current flows through the circuit. Okay. What is the third effect? Yes, this is called magnetic effect. That is called magnetic effect. See, it's very, very important. This effect we can study, or we are going to study about this magnetic effect in this chapter. Okay, that is called magnetic effect of electric current. See, let me study how the magnetic effect is generated when the current flows through the circuit and all. Okay, see, in this chapter, in this particular chapter, magnetic effect of electric current, we are going to study about how the magnetic field is generated when electric current flows through the conductor or electric current flows through the circuit. Okay, it explains how the magnetic field is generated and what is magnetic field lines and who invented this magnetic field and how he was invented this and all. Okay, we will study one by one. So just remember this: when the electric current flows through the circuit, it generates or mainly it produces three types of effects. First one is heating effect, and second one is chemical effect, and third one is magnetic effect. Okay. In our today's class, we just learn the concept one by one. Okay. See, in particular this topic, we are going to learn some concept about magnetic field, what is magnetic field and how it is generated and all. Okay. See students, before going to study about this magnetic field generation due to electricity, we should know or we should remember something which is related to this concept. Firstly, we will see some history, okay, how that magnetic field is invented and who invented this and how this was invented. Okay, let's see one by one. See, just observe this picture. Okay, this is the picture of one famous scientist. His name is Hans Christian Ørsted. His name is Hans Christian Ørsted. He is a very, very famous scientist in the 19th century. Okay, he is the famous scientist in 19th century. He only invented magnetic field. Okay, he invented the magnetic field or magnetic effect of electric current. See how he invented this. he made some experiment, okay, in his lab. He just to do some experiment with the help of some circuits, and due to that he invented that magnetic effect of electric current. Okay, we'll see how he invented this and all. Okay, see, though his observation hosted show that, see, he do some experiment with the help of circuits. Okay, he find out this magnetic field or magnetic effect of electric current due to some experiment. See, ಇವ್ರು ಏನ್ ಮಾಡ್ತಾರೆ, he use some instruments, okay, ಕೆಲವೊಂದು ಕಾಂಪೋನೆಂಟ್ ಅನ್ನ ಯೂಸ್ ಮಾಡಿ he made one circuit. See, for example, this is one circuit. We all are very well known about the circuits because we already learned about this concepts in electricity topic, right? Yes, isn't it, students? See, this is called resistance and this is our key which is connected to battery, and other component is also there in circuit. Imagine, he used this circuit and one compass, okay, one compass near this circuit. So due to this, accidentally he find out some magnetic effect is generated when electric current flows through this circuit. Okay, see, rain ಮಾಡ್ತಾರೆ, Hans Oersted invented this magnetic effect of electric current. ಈ ಸೈಂಟಿಸ್ಟ್ ಏನ್ ಮಾಡಿದ್ದಾರೆ, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಇಫೆಕ್ಟ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಕರೆಂಟ್ ಅನ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡಿದ್ದಾರೆ. ಹೌ ಹೇಗೆ ಫೈಂಡ್ ಔಟ್ ಮಾಡಿದ್ದಾರೆ? ಇನ್ ಹಿಸ್ ಲ್ಯಾಬೋರೇಟರಿ ಹಿ ಯೂಸ್ ಸಮ್ ಕಾಂಪೋನೆಂಟ್ಸ್ ಅಂಡ್ ಮೇಕ್ ಒನ್ ಸರ್ಕ್ಯೂಟ್. ಓಕೆ, ಕೆಲವೊಂದು ಕಾಂಪೋನೆಂಟ್ಸ್ ಅನ್ನ ತಗೊಂಡು ಒಂದು ಸರ್ಕ್ಯೂಟ್ ಅನ್ನ ಜನರೇಟ್ ಮಾಡ್ತಾರೆ. ಸೊ ಇವರು ಬೇರೆ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡುವಾಗ ಸರ್ಕ್ಯೂಟ್ ಅನ್ನ ಜನರೇಟ್ ಮಾಡಿ ಮಾಡ್ತಾ ಇರುವಾಗ ಏನಾಗತ್ತೆ, ಹಿ ಯೂಸ್ ಒನ್ ಕಾಂಪೋನೆಂಟ್ ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಕಂಪಾಸ್ ಬಾಕ್ಸ್, ರೈಟ್? ಕಂಪಾಸ್ ಅನ್ನ ಏನ್ ಮಾಡಿರ್ತಾರೆ, ಸರ್ಕ್ಯೂಟ್ ಹತ್ರ ಇಟ್ಟಾಗ ಆಕ್ಸಿಡೆಂಟಲಿ ಇಟ್ ಶೋಸ್ ಸಮ್ ಡಿಫ್ಲೆಕ್ಷನ್. ವೆನ್ ಇಟ್ ಶೋಸ್ ಸಮ್ ಡಿಫ್ಲೆಕ್ಷನ್ಸ್, when the current flows through the circuit, that time this compass shows some deflections. Due to that deflections, he conclude that, ಅವ್ರು ಏನಂತ ಕನ್ಕ್ಲೂಷನ್ ಕೊಡ್ತಾರೆ, here there is some link between the magnetic effect and electric current. So due to this experiment, he invented magnetic effect of electric current. See, here next, using this experiment, more components are works, that is radio, television and fiber optics are created by using this technology. Okay, see, this Hans Oersted find out the magnetic effect of electric current. See, let us see how he was invented this and all. Okay, see here, just observe this circuit, students. Just observe this circuit. See what this component is called. What is this component is called? We know that what is cell, what is battery, what is plug key, and what is resistance and all, because we already learned this from our chapter electricity, right? Yes, see, this is battery. See, this is battery. How the battery is generated? It is due to the number of cells are connected end by end and finally become battery. Okay, see, all the component here, the all this is all are the different cells, each cell having positive and negative terminals. We know that battery having positive and negative terminals. See, this larger end indicates the positive and this shorter line indicates the negative, right? Idanna electricity chapter alli ಏನು ಮಾಡಿದವ, ಸ್ಟಡಿ ಮಾಡಿದವ. ಸಿ, ಈ ಸರ್ಕ್ಯೂಟ್ ಅಲ್ಲಿ ಕಾಂಪೋನೆಂಟ್ಸ್ ಬಗ್ಗೆ ಹೇಳ್ತಾ ಇದ್ದೇನೆ. This is battery, this is positive end of the battery and this is the negative terminal of the battery. See, next, this positive end is connected with the plug key. We know that this is the symbolic representation of key, right? It is in off state. When it is in on, this is the on state of the key. Okay, this is the on state. Next, here R represents what? What is R? R is nothing but it is resistance, right? Resistance is used to vary the current in the circuit. Okay. See, this is the X and Y two terminals, and this red line indicate the conductor. See, it's very, very important in this circuit. This line, red line indicates the conductor. Okay, this is the two ends of the conductor, X and Y. See, what is this, students? Can you see this? See, this having needle, right? Okay, this is called compass. This is called compass. Idanna ಏನಂತ ಕರೀತೇವೆ? Compass ಅಂತ ಕರೀತೇವೆ. We know that generally this compass having two needles, right? It having two needles. That needle is made up of magnet. See this. What is the use of this compass? Compass ಅನ್ನು ಯಾಕೆ ಯೂಸ್ ಮಾಡ್ತೇವೆ? The main use of this compass is it shows the direction, right? Whether it may be north, south, east or west. In which direction it's used to find out the direction. Okay, that's why mainly the compass is used in navigation processes, right? Navigation process ಅಲ್ಲಿ ಏನು ಮಾಡ್ತೇವೆ? Compass ಅನ್ನು ಯೂಸ್ ಮಾಡ್ತೇವೆ ಅಲ್ವಾ? Why we use the compass in navigation process? Because it shows the directions due to that deflection in the needle, right? Okay. See, one compass is placed near this circuit. This is the experimental setup what that Oersted made to find out the magnetic effect. Okay. See, how he find out this? Let us study. See here, first connect all these circuits as shown in the diagram. Okay. Positive terminal of the battery is connected to key, and another end of the key is connected to resistance, and another end of the resistance is connected to conductor one end, and another end of the conductor is connected to negative terminal of the battery. This is about the circuital connection. Okay, idu circuit alli mado connections. Next, see what happens here. He just place one compass near this circuit. Okay, then when the plug is closed, means the circuit is in on state. Okay, when the plug key is closed, we can say that the circuit is in on state and the current starts flowing in the circuit. Okay, this current I, current is mentioned in the letter I, right? We know that. Yes, this starts flowing in the circuit. At that time, what he observed, when the current flows through this circuit, see here the compass is already near this circuit, right? ಈ compass ಅನ್ನು ಏನು ಮಾಡಿದ್ದಾರೆ? ಈ circuit ನ near ಅಲ್ಲಿ place ಮಾಡಿದ್ದಾರೆ ಅಲ್ವಾ? So when the current starts flowing in the circuit, what happens? He observed some deflections or some fluctuations in the needle of this compass box. ಏನಾಗುತ್ತೆ? ಕರೆಂಟ್ ಈ ಸರ್ಕ್ಯೂಟ್ ಅಲ್ಲಿ ಫ್ಲೋ ಆಗೋಕೆ ಸ್ಟಾರ್ಟ್ ಆದಾಗ this compass shows some deflections. Okay, whether it may be in the direction of south, north, east or west, anything, but still this compass box show some deflection. When it shows, when the current starts flowing in the circuit, that time this compass shows some deflections. So at that time, this scientist Oersted noticed this. Okay, he noticed some deflections in the compass when the current starts flowing in the circuit. Then he concluded that there is some relationship or some link between the current and magnetic field. There is some relationship or link between the magnetic field and current. That's why this compass shows some deflections. Okay, that is the conclusion what he give after this experiment. Okay, actually he find out this in accidentally. ಓಕೆ, ಇವರು ಬೇರೆ ಯಾವುದೋ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಅನ್ನ ಮಾಡ್ಲಿಕ್ಕೆ ಏನ್ ಮಾಡಿದ್ದಾರೆ, ಈ ಸೆಟಪ್ ಅನ್ನ ರೆಡಿ ಮಾಡಿರ್ತಾರೆ Oersted. But at that time, one compass is accidentally placed near this circuit. Okay, when he start his experiment, when the plug key is closed and then current is start flowing in the circuit, when the current reaches this end, X and Y, this is the two ends of the conductors, what we study now, right? Okay. When the current flows through these conductors, at that time, he observes some fluctuations or some movement in the needle of this compass. Okay. Then he concluded that when the current flows through the circuit, there is some magnetic effect is generated. That is the conclusion. So, he experiment ಮಾಡಿ ಏನು ಮಾಡ್ತಾರೆ? He invented how the magnetic effect is generated when the current flowing through the circuit. So, this is about the history of the generation of magnetic effect or invention of magnetic effect. Then, who find out this or who invented this magnetic effect, students? The famous scientist Hans Christian Ørsted invented this magnetic effect of electric current. How he invented? With the help of this circuit, he proved that some magnetic effect is generated when electric current flows through the circuit. With the help of this experiment. Okay, ಈ experiment ಅನ್ನ ಮಾಡಿ ಇದರ ಹೆಲ್ಪ್ ಇಂದ ಏನು ಮಾಡ್ತಾರೆ ಅವರು? ಸರ್ಕ್ಯೂಟ್ ಅಲ್ಲಿ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗುವಾಗ there is some magnetic effect is also generated in the circuit. That is the concept. Got clear? Okay. Next one, before going to study about the magnetic effect generated in a conductors, we should know some basic concepts, right? That is magnets. Yes, I hope you all are very, very well known about this magnets, right? Yes or no, students? Yes. You know that what is magnet, how it look like and all, right? What is magnet? What is magnet? I think you use these magnets in your childhood days, right? Childhood days, you use these magnets and play some games and all, right? Yes. So that time, we just see these magnets. Until now, we use this magnet for different purposes. Scientists used this in labs, right? To make some circuits and find out some invention. Okay, find out some experiments. That time we use the magnets. Okay, then what is magnet? What is magnet? We know that magnet attracts some objects, right? See, for example, we have one magnet. When you take that magnet near the iron, what happens? Near that iron, you just take that magnet near to iron. What do you feel? That some attraction between that magnet and iron, right? So that is called magnet. What is magnet? Magnet is, it's a substance which having the characteristic of attraction, or it having the property of attraction when it close to the iron or iron-like substances. Okay, this is the definition of magnet. Then what is magnet? Magnet is nothing but it is the substance that attracts iron or iron-like substances. That is called magnet. Iron-like substances, or like it attracts cobalt, nickel and all. Okay, it attracts cobalt, nickel, etc. Okay, so generally it having the attraction property. That is called magnets. Okay, see students, how many types of magnets you see? How many types of magnets are there? I'm not asking about all types of magnets. Just remember some types of magnets. Okay, see, just observe this diagram. Here I mentioned different types of magnets pictures. Okay, see, first one is horseshoe magnet, right? This one is horseshoe magnet, and second one is ring magnet. It is in ring shape, or it is in circular shape. That's why we called it as ring magnet, right? Okay, then third one is U-shaped magnet. We know that U-shape, right? see why we called it as U-shaped magnet, because it is in U-shape. Okay, so this is the third type of magnet, that is U-shaped magnet. And next one is bar magnet. Yes, it's very, very important. Almost all the time we use this bar magnets, right? Okay. See, next one is cylindrical magnet. It is in cylindrical shape. That's why we called it as cylindrical magnet. Okay. See, these are the types of magnets. ಐ ಹೋಪ್ ನೀವು ಈ ಮ್ಯಾಗ್ನೆಟ್ಸ್ ಅಲ್ಲಿ ಕೆಲವೊಂದು ಮ್ಯಾಗ್ನೆಟ್ಸ್ ಅನ್ನ ನೋಡಿರ್ತೀರಾ ಅಲ್ವಾ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಲೈಕ್ ದಿಸ್ ರಿಂಗ್ ಲೈಕ್ ಮ್ಯಾಗ್ನೆಟ್ ಆರ್ ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್ ಅಂಡ್ ಆಲ್. ಐ ಹೋಪ್ ಯು ಲರ್ನ್ about this or you see about this, right? Okay. See, these all about the definition and types of magnets. Magnet is a substance which attracts the iron or iron-like a substance, and we can see many types of magnets. How you differentiate this different types? Due to the that's shape, right? Based on that shape we can write different types of magnets. We can see different types of magnets. ಅದು ಯಾವ ಶೇಪ್ ಅಲ್ಲಿ ಇದೆ ಅನ್ನೋದ್ರ ಮೇಲೆ ಅದಕ್ಕೆ ಕೆಲವೊಂದು ನೇಮ್ ಅನ್ನ ಕೊಟ್ಟಿದ್ದಾರೆ, ರೈಟ್? ಅದ್ರ ಬೇಸ್ ಮೇಲೆ ಏನ್ ಮಾಡ್ತೇವೆ, ಟೈಪ್ಸ್ ಆಫ್ ಮ್ಯಾಗ್ನೆಟ್ಸ್ ಅನ್ನ ಮೆನ್ಷನ್ ಮಾಡ್ತೇವೆ. ಸಿ ದೆನ್ ವಾಟ್ ಈಸ್ ದಿ ಜನರಲ್ ಪ್ರಾಪರ್ಟೀಸ್ ಫಾರ್ ಮ್ಯಾಗ್ನೆಟ್ಸ್? See, magnets are available in different shapes, right? But all these types of magnets have some common properties. Okay, so what are those? Let us see one by one. See, first property, every magnet has two poles, that is north and south. Every magnet has two poles, right? See, observe these pictures. Here I mentioned different types of magnets, right? All the magnets having two poles. What are those? North and south poles. It is mentioned in N and S, right? See here, every types of magnets having two poles, N and S, north and south poles. Observe these pictures. Okay, different types of magnets having two poles. Okay, that is first property. Every magnet has two poles. Those two poles are north and south poles. This is the first property of magnet. Let us move second one. We know that we already learned this concept in electricity, right? We know that when the positive charge and negative charge, when the like charges repel and unlike charges attract each other. Like that, here also we consider two poles, that is north and south pole. When the like poles are come close to each other, what it feels? It feels some repulsion. For example, when north and north pole are come close to each other, here these are like poles, right? So generally it get repel each other. It get repel. Okay, if suppose north is come close to south pole of the another magnet, what happens here? Attraction takes place, because these two are considered as unlike poles, right? Unlike poles. We know that like poles repel and unlike poles attract each other. This is the second property of the magnet. Okay, first property tells that every type of magnet generally having two poles. One is north and another one is south pole. Okay, then second property tells about attraction and repulsion. So like poles repel each other and unlike poles are attract each other. This is the second property of the magnet. And next one is a freely suspended bar magnet. See, this is bar magnet, right? Observe this picture. Fourth one shows the bar magnet. See, this is in the shape like this, bar magnet. It having two poles. One is south and another one is north pole. When we freely suspend this magnet, freely suspension means either freely move. Okay, so just hang this magnet freely suspended. When it is freely suspended, what happens? We know that earth also having attraction property, right? Earth having, again it considered as south and north poles, and it attracts the objects towards this. We know that when we throw some objects upwards, what happens? It come back to the earth, right? Why? Because this earth having the attraction property, right? So similarly here, when we freely suspend that bar magnet, what happens? Its pole get attracted towards this geometrical poles. Okay, geometrical pole is nothing but pole of the earth. Suppose we suspended this north pole in downward, it attract towards the south pole of the earth. Okay, if suppose we suspended south pole downwards and north in upwards, so the south pole of the bar magnet attracted towards the north pole of the earth. That is the meaning. So these all are the properties we can see in bar magnets. Okay, this is about the bar magnets. Let us see how the magnetic field is generated in magnets. Okay, see, this is very important concept. See how the magnetic field is generated, then what is magnetic field of magnet and all. Let us see. See students, we know that for example, consider two bar magnets. Okay, consider two bar magnets. Again, each magnet having two poles, south and north poles, right? Okay. We know that when one magnet come close to another, it get attracted, right? When their unlike poles are come close, they get attract each other, right? Yes. Depending upon this attraction or repulsion property, we can say that what is magnetic field. Okay, ಬೇಸ್ ಮೇಲೆ ಏನ್ ಮಾಡ್ತವೆ, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಎಲ್ಲಿ ಜನರೇಟ್ ಆಗತ್ತೆ ಅಥವಾ ಹೇಗೆ ಜನರೇಟ್ ಆಗತ್ತೆ ಅನ್ನೋದನ್ನ ಏನ್ ಮಾಡ್ತವೆ, ಹೇಳ್ತವೆ. ಸಿ ಸ್ಟೂಡೆಂಟ್ಸ್, ವಾಟ್ ಈಸ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಡೆಫಿನೇಷನ್ ಟೆಲ್ಸ್? See, magnetic field is nothing but the region around a magnet where the force of attraction or repulsion can be detected. Okay, and that is called magnetic field. Magnetic field is nothing but this is the particular region around the magnet. For example, this is magnet. Okay, some particular regions here field is generated, not all the regions. Okay, ಎಲ್ಲ ರೀಜನ್ ಅಲ್ಲೂ ಏನಾಗಲ್ಲ, ಇಲ್ಲಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗಲ್ಲ. ಇನ್ ಸಮ್ ಪರ್ಟಿಕ್ಯುಲರ್ ರೀಜನ್ ಓನ್ಲಿ ಇಟ್ ಫೀಲ್ಸ್ ಸಮ್ ಅಟ್ರಾಕ್ಷನ್ ಆರ್ ರಿಪಲ್ಷನ್. ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್. ಓಕೆ, ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್. ಹಾಗಾದ್ರೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಡೆಫಿನೇಷನ್ ಪ್ರಕಾರ, the region around a magnet where the force of attraction or repulsion takes place. But how we can say that this particular, how much of reasons shows the magnetic field? How we can say that this much only shows the magnetic field, this region only shows the magnetic field? How we can say that? ಹೇಗೆ ಹೇಳ್ತೀರಾ? ಪರ್ಟಿಕ್ಯುಲರ್ ಆಗಿ ಇದೇ ರೀಜನ್ ಅಲ್ಲಿ ಅಷ್ಟೇ ಏನ್ ಮಾಡತ್ತೆ, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಅನ್ನ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡತ್ತೆ ಅಂತ ಹೇಗೆ ಹೇಳ್ತೇವೆ? ಹೇಳಕ್ ಆಗಲ್ಲ ಅಲ್ವಾ? ಸೊ ವಿ ವಿಲ್ ಸಿ ಒನ್ ಆಕ್ಟಿವಿಟಿ. ವಿತ್ ದ ಹೆಲ್ಪ್ ಆಫ್ ದಿಸ್ ಆಕ್ಟಿವಿಟಿ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಲರ್ನ್ ದಿಸ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಡೀಪ್ಲಿ. ಓಕೆ, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಹೇಗೆ ಜನರೇಟ್ ಆಗುತ್ತೆ ಅನ್ನೋದನ್ನ ನಾವು ಒಂದು ಆಕ್ಟಿವಿಟಿ ಮಾಡಿ ನೋಡೋಣ, ಆಯ್ತಾ? ಸಿ, ಇಫ್ ಸಪೋಸ್ consider here you have one paper. Okay, just take a piece of paper. See, for example, this is the white sheet. Okay, when you place one magnet in the middle of this paper or some place inside that paper. Okay, ಒಂದು ವೈಟ್ ಶೀಟ್ ಅನ್ನ ತಗೊಂಡು ಅದ್ರ ಒಳಗಡೆ ಏನ್ ಮಾಡಿದ್ದೇವೆ, ಒಂದು ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್ ಅನ್ನ ಪ್ಲೇಸ್ ಮಾಡಿದ್ದೇವೆ. See, this magnet contain two poles, south and north poles, right? Okay, this contain south and north poles. Then take some fine powder of iron. Okay, iron ಅನ್ನ ಫೈನ್ಲಿ ಪೌಡರ್ ಮಾಡಿರೋ ಐರನ್ ಅನ್ನ ಏನ್ ಮಾಡ್ತಾ ಇದ್ದೇವೆ, we just randomly place those iron in this sheet. Okay, ಈ ವೈಟ್ ಶೀಟ್ ಮೇಲ್ಗಡೆ ಏನ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ, ಐರನ್ ಪೌಡರ್ಸ್ ಅನ್ನ ಪ್ಲೇಸ್ ಮಾಡಿ, randomly placed. Okay, See, after that, just tap the one end of the paper. One end anna en madi, just tap madi. Okay. Then after some time, what we observe here, after some times, what we observe, see here, generally, this all the iron pieces get attract, or some iron pieces get attracts in a particular region of this magnet. Okay, magnet in a particular regions ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಆ iron pieces attract ಆಗುತ್ತೆ. Like this is bar magnet. You just place the finely powdered iron in randomly inside this, and after sometimes what happens, they all are arranged. They all are arranged in some pattern. Okay, in some particular regions they come and arrange like this. So like this they get arranged in outer side of the magnet and in pole also. Okay, so ಇಲ್ಲಿ ಏನು ಮಾಡ್ತಾ ಇದ್ದೇವೆ ನಾವು, ಒಂದು ವೈಟ್ ಶೀಟ್ ಮೇಲ್ಗಡೆ just randomly place some iron fillings. Okay, see, when just tap one end of this paper, what happens, after some time all the magnetic all that iron fillings, okay, are come close to this magnet and they get arranged like this. So this particular field or this particular region is called magnetic field. Okay, ಇಲ್ಲಿ ಯಾವ ರೀಜನ್ ನಲ್ಲಿ ಐರನ್ ಅಟ್ರಾಕ್ಟ್ ಆಗಿದೆಯೋ ಅದಷ್ಟು ರೀಜನ್ ಅನ್ನ ಏನಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೇವೆ, that region is called magnetic field is generated in that particular regions. See here, this picture explains clearly. See, this is considered as white sheet, and here we just place some finely powdered iron, and then after sometimes they all are get arranged like this. Why they get arranged like this? Because in particular region or in particular place it feels some attraction towards this magnet. Okay, we know that magnet attracts iron particles, right? Or magnet attracts the iron substances. So that's why these all iron get attracted near this magnetic field magnets, and they get arranged like this. They all get arranged like this. Okay, see, like this it get arranged. So what happens at that time, this also arranged in pole. In pole region also it get attracts. Okay, observe this pictures carefully. So this particular region we can say that magnetic field is generated. ಆಯ್ತಾ, ಹೀಗೆ ಮಾಡೋದ್ರಿಂದ ಏನಾಗುತ್ತೆ, ಪರ್ಟಿಕ್ಯುಲರ್ ಯಾವ ರೀಸನ್ ನಲ್ಲಿ ಐರನ್ ಮ್ಯಾಗ್ನೆಟ್ ಜೊತೆ ಅಟ್ರಾಕ್ಟ್ ಆಗಿ ಒಂದು ಪ್ಯಾಟರ್ನ್ ಅನ್ನ ಫಾರ್ಮ್ ಮಾಡುತ್ತೋ ಆಗ ಅಲ್ಲಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಇಸ್ ಜನರೇಟೆಡ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಓಕೆ, ದಿಸ್ ಇಸ್ ದಿ ಕಾನ್ಸೆಪ್ಟ್. ದೆನ್ ವಾಟ್ ಇಸ್ ದಿ ಸ್ಟೇಟ್ಮೆಂಟ್ ಆಫ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್? Magnetic field statement ಏನ್ ಹೇಳುತ್ತೆ? It says that the region around a magnet where the force of attraction or repulsion can be detected is called magnetic field. It is called magnetic field. We can use this activity and explain the things, or illa andre naven madbodu, we can use compass also. Okay, by using this compass and find out the magnetic field with the help of this. How we can find out with the help of this compass? See here again, here we consider one bar magnet, it having south and north poles. Okay, then just take one compass, and place that compass near this magnet. See here we show so many compass box positions, right? ಇಲ್ಲಿ ತುಂಬಾ ಕಂಪಾಸ್ ಬಾಕ್ಸ್ ಇದೆ ಅಂದ್ರೆ ಅರ್ಥ ಏನು, ಇಲ್ಲಿ ಇಷ್ಟೊಂದು ಕಂಪಾಸ್ ಬಾಕ್ಸ್ ಅನ್ನ ತಗೊಂಡಿದ್ದೇವೆ ಅಂತ ಅಲ್ಲ. that is the what is the meaning here? We just consider only one compass and it is placed in different places. Okay, it is placed in different regions around this magnet. Okay, first we place this in this position. What happens? It get attracted towards this magnet. So then how it shows attraction? at that time this needle get deflected. Okay, ಈ needle ಏನಾಗುತ್ತೆ, ಡಿಫ್ಲೆಕ್ಟ್ ಆಗುತ್ತೆ. ಡಿಫ್ಲೆಕ್ಟ್ ಆಗಿ ಅದು ಎಲ್ಲಿ ಸ್ಟಾಪ್ ಆಗುತ್ತೋ ಆ ರೀಸನ್ ಅನ್ನ ಏನ್ ಮಾಡಿದಾವೆ, that region we should mark here. Okay, this is first region. Then again place this compass box in this place and find out the region where it get attracted and mark that point. And again same here, place here and mark that point where it get attract and show some deflection. So like that in different places we just put this or place this compass and test the magnetic field. Okay, test the attraction and mark those points and finally join all those points. Last ಅಲ್ಲಿ ಏನ್ ಮಾಡ್ತೇವೆ, ಎಲ್ಲ ಪಾಯಿಂಟ್ಸ್ ಅನ್ನ ಏನ್ ಮಾಡಿದಾವೆ, ಜಾಯಿನ್ ಮಾಡಿ ಇಲ್ಲಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಅನ್ನ ಶೋ ಮಾಡ್ತಾರೆ. ದಟ್ ಈಸ್ ದಿ ಕಾನ್ಸೆಪ್ಟ್ ವಾಟ್ ವಿ ಅಬ್ಸರ್ವ್ ಹಿಯರ್. ಓಕೆ, ಸೊ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ this is the region around a magnet where the force of attraction or repulsion can be detected. That is called magnetic field. That is called magnetic field. So with the help of these two activities, this is activity 1 and this is activity 2. With the help of these two activities ನಾವೀಗ ಏನ್ ಮಾಡಿದಾವೆ, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಅಂದ್ರೆ ಏನು ಅನ್ನೋದನ್ನ ಕರೆಕ್ಟ್ ಆಗಿ ತಿಳ್ಕೊಂಡಿದ್ದೇವೆ ಅಲ್ವಾ. ಯಾವುದೋ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ರೀಜನ್ ನಲ್ಲಿ ದೇ ಗೆಟ್ ಅಟ್ರಾಕ್ಟೆಡ್ ಟುವರ್ಡ್ಸ್ ದ ಮ್ಯಾಗ್ನೆಟ್. ಓಕೆ, ಅಟ್ರಾಕ್ಷನ್ ಮತ್ತೆ ರಿಪಲ್ಷನ್ ಒಕ್ಕರ್ ಆಗತ್ತೆ. ದಟ್ ಪರ್ಟಿಕ್ಯುಲರ್ ರೀಜನ್ ಈಸ್ ಕಾಲ್ಡ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್. ಆ ಪರ್ಟಿಕ್ಯುಲರ್ ರೀಜನ್ ಅನ್ನ ಏನಂತ ಕರಿತೇವೆ, ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್. ಐ ಹೋಪ್ ಯು ಆಲ್ ಗಾಟ್ ಕ್ಲಿಯರ್ ದಿಸ್ ಕಾನ್ಸೆಪ್ಟ್, ರೈಟ್? Okay, let us see what is field lines. What is magnetic field lines? See, this is also another important concept which it asks in your exams. Okay, they ask some question related to magnetic field and magnetic field lines also. Then what is magnetic field lines? How it is generated? See, with the help of the magnetic field we can easily explain magnetic field lines. Okay, ಈಗ magnetic field ಹೇಗೆ ಜನರೇಟ್ ಆಗುತ್ತೆ ಅನ್ನೋದನ್ನ ಏನ್ ಮಾಡಿದಾವೆ, we just study about this with the help of two activities, right? Okay, with the help of this we can define or we can write the concept, that is what is magnetic field lines. Okay, see here, magnetic field line is generated due to the magnetic field. Okay, magnetic field inda enagutte, magnetic field lines generate agutte. What is magnetic field lines? This is an imaginary lines of magnetic field around the magnet. This is some imaginary line around the magnet. See, this is considered as magnet. It having two poles, south and north. Okay, when we see some magnetic field effect around this magnet, right? See, like this. Okay, then what is magnetic field lines? It is nothing but when you join all these lines. See, when you join all these dotted points, what you get? You get one imaginary line. Okay, some imaginary lines are generated due to the magnetic field. Okay, see, this is also generated in near this pole also. Near this pole also here some field is generated. Okay, due to that we just draw these lines. So these all imaginary lines which is generated around the magnet is called as magnetic field lines. This is called as magnetic field lines. Okay, this is the definition of magnetic field lines. See here, observe this picture. See, these all are the imaginary lines which is formed around this magnet, right? How we can draw this imaginary lines? This is with the help of magnetic field generation around this magnet, right? ಎಲ್ಲೆಲ್ಲಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಜನರೇಷನ್ ಇದೆಯೋ ಅಲ್ಲೆಲ್ಲ ಏನಾಗುತ್ತೆ, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. ದಿಸ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ಇಟ್ ಈಸ್ ಇಮ್ಯಾಜಿನರಿ ಲೈನ್ಸ್ ಆಫ್ magnetic field around a magnet. This is called imaginary lines. See, this about the magnetic field lines. Later we will discuss about this direction of field lines and all. Okay, I hope you got clear about the concept, what is magnetic field and what is magnetic field lines. Got cleared? Yes, I will explain one more times. What is magnetic field? Magnetic field is the region or it is some particular place where the magnet feels some attraction or repulsion force. That particular region is called magnetic field. Okay. Then what is magnetic field lines? It is the imaginary lines of the magnetic field. That magnetic field forms some imaginary lines around the magnet. That lines are called magnetic field lines. This is called magnetic field lines. Got clear? Okay, let us move next one, and it is also very important, that is properties of magnetic field lines. See students, in your exams they ask almost maximum times they ask this question, write the properties of magnetic field lines. They ask maybe sometimes 2 marks or sometimes 3 marks. Okay, so you should remember this concept and write. It's very important concept, properties of magnetic field lines. I will explain with the help of these images. Okay, see here, first property tells that field lines arise from north pole and end into the south pole of the magnet. We know that magnet having two poles, right? Magnet having two poles, one is north and another one is south pole, right? Okay, every magnet having two poles, south and north poles, right? Okay, consider one bar magnet here. See, field lines arise from north pole to south pole. It is always arise from north to south. See here, it is always like this, north to south and north to south, right? North to south directions. So here the arrow mark shows like this. Why it shows like this? Why it shows like this? See here, because it is from north to south, right? It is from north to south. This is the first property. You should remember this. Field lines always arise from north pole to south pole. It starts or it arises from north and end into south. Or we can write like this also, that magnetic field line emerge from north and it merge in south pole. Okay, that's why the direction is like this. We can show the direction from north to south. Here also it shows from north to south. This is the first property. Let us move second one. Field lines are closed and continuous curves. It is closed and continuous curves. See this? It is always closed and continuous like this, north to south and north to south like this, right? It is continuous and closed curves. We know that continuously forming in closed curves. Okay, this is the second property. And what is the next property tells? The density of the magnetic field lines are more in their poles. Density of the magnetic field lines are more. See, observe this. This is pole, right? South and north pole. Here also magnetic field lines are generated, right? Some field lines are generated in poles also. So as compared to this region, the pole region, magnetic field line is generated more. Okay. Pole allige compare ಮಾಡಿ ಇಲ್ಲಿ ಸರೌಂಡಿಂಗ್ ಗೆ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ pole ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, magnetic field lines generation is more. That is the third property. Density is nothing but here more magnetic field lines are generated in the pole of the magnets as compared to its surroundings. Okay, ಇಲ್ಲಿ ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಪೋಲ್ಸ್ ಅಲ್ಲಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಆರ್ ಜನರೇಟೆಡ್ ಮೋರ್. ಓಕೆ, ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಡೆನ್ಸಿಟಿ ಆಫ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಆರ್ ಮೋರ್ ಇನ್ ದರ್ ಪೋಲ್ಸ್. So this is the third property and another important property. Next one, field lines never intersect each other. See here, they never get intersect each other. What it means? What is intersect? Intersect is nothing but merge, right? Or what we call overlap. Overlap or merge or intersect, all are same. Okay. Here the field lines are never intersect each other. See here, all are separate, right? See, like this. They never intersect or merge each other. ಹೌದಾ ಮರ್ಜ್ ಆಗೋದು ಅಂದ್ರೆ ಏನು ಒಂದ್ರ ಮೇಲೊಂದು ಓವರ್ಲ್ಯಾಪ್ ಆಗಬೇಕು ಲೈಕ್ ದಿಸ್ or intersect, right? No, here the field lines never intersect each other. This is the another one important property we can see here. Okay, next one. Next, fifth property, the direction of field lines inside a magnet is from south to north. See, this is also one of the important property. See here, we know that always field lines are from north to south, right? In previous property test like that, field lines arise from north pole and it end into south pole, right? Okay, but in case of pole, when you come to the concept of pole, inside this magnet, see, these all are outside magnet lines, right? This all shows the magnetic field lines generated outside the magnet. Howda? These all shows the outside magnetic field lines. Here they consider what about the direction of inside a magnetic field lines in this magnet. See, inside it always from south to north. It always from south to north. Okay. Magnet in a inside a lane agata, that field line or field line is always from south to north. That is the meaning. Okay. Outside it is from north to south. Okay. And outside the magnet it is from north to south, but inside the magnet it is always from south to north. Inside the magnet it is always from south to north. That is the another one important property. Next, sixth one, the relative strength of the magnetic field is shown by degree of closeness of field lines, right? What is this degree of closeness of field lines? See, observe this outside magnetic field and magnetic field lines in poles. Okay, magnet in outside ಅಲ್ಲಿ ಜನರೇಟ್ ಆಗಿರೋ ಫೀಲ್ಡ್ ಲೈನ್ಸಿಗೂ ಹಾಗೂ ಪೋಲ್ ಅಲ್ಲಿ ಜನರೇಟ್ ಆಗಿರೋ ಫೀಲ್ಡ್ ಲೈನ್ಸಿಗೂ ಏನಾದರೂ ಡಿಫರೆನ್ಸ್ ಇದೆಯಾ? Yes, there must be some difference. See, compared to this outside field lines, this field lines in the pole is very, very high, right? Very, very large number of field lines are generated in pole point. That it means here the strength of the magnetic field is shown by degree of closeness. See here in the outer side, the closeness is very, very less, but in pole side, very nearly the magnetic field lines are generated, right? See this, they are very, very close to each other. What it tells? It tells that the strength is more in pole as compared to outside of the magnet. That is the meaning. So this is the another important property of the magnetic field lines. Okay, just remember all these properties. It's very, very important. First property tells that always magnetic field lines are from north to south. Okay, this is first property as compared to outside. Next one tells that field lines are closed and continuous curves. They are closed and continuous curves. And third property tells that density of magnetic field lines are more in their poles. Always density of the magnetic field lines in pole is more. Okay, that is the third property. And next property tells that never and ever field lines intersect each other. Okay, they never intersect each other. And next property tells that direction of field lines inside the magnet. It is always from south to north. It is always from south to north. Next property tells that relative strength of the magnetic field is decided at the closeness of the field lines. Okay, these all about the properties of magnetic field lines. Let us see or let us discuss how magnetic field is generated due to a current carrying conductors. Okay, see already now ಹೇಳಿದವೆ Hans Oersted ಏನ್ ಮಾಡಿದ್ದಾರೆ ಸರ್ಕ್ಯೂಟ್ ಅನ್ನ ಯೂಸ್ ಮಾಡಿ ಪ್ರೂವ್ ಮಾಡಿದ್ದಾರೆ ಅಲ್ವಾ ಸರ್ಕ್ಯೂಟ್ ಅಲ್ಲಿ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗ್ತಾ ಇರುವಾಗ ಏನಾಗುತ್ತೆ there might be some magnetic effect is also generated, right? See the same concept here we are going to observe, but here one more thing is extra. Okay, one more important concept is also there. Let me see. Here we consider one circuital connections, and here this time the compass is connected with this circuits. So in Hans Oersted prove that when the compass is outside the circuit but it's very near to the circuit, that time magnetic effect is generated when current flows through the circuit. ಹೌದಾ Oersted ಏನ್ ಮಾಡಿದ್ದಾರೆ ಕಂಪಾಸ್ ಅನ್ನ ಸರ್ಕ್ಯೂಟ್ ನಿಯರ್ ಅಲ್ಲಿ ಇಟ್ಟು ಸರ್ಕ್ಯೂಟ್ ಅಲ್ಲಿ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗೋವಾಗ ಕಂಪಾಸ್ ನೀಡಲ್ ಮೂವ್ ಆಗೋದನ್ನ ನೋಡಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಇಫೆಕ್ಟ್ ಜನರೇಟ್ ಆಗಿದೆ ಅನ್ನೋದನ್ನ ಹೇಳಿದ್ದಾರೆ. ಹಿಯರ್ ದ ಸೇಮ್ ಕಾನ್ಸೆಪ್ಟ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಸ್ಟಡಿ, ಬಟ್ ದಿಸ್ ಟೈಮ್ ವಿ ಅಬ್ಸರ್ವ್ ಒನ್ ಮೋರ್ ಎಕ್ಸ್ಟ್ರಾ ಥಿಂಗ್. ವಾಟ್ ವಿ ಅಬ್ಸರ್ವ್ ಹಿಯರ್, ಲೆಟ್ ವಿ study now. See here, this is the circuital setup. Again here the large line indicates the positive terminal of the battery and short line indicates negative terminal. The battery is connected to the plug key here, right? Plug key, and this some conductor is also connected here. See, these lines are conductors. Okay, then here one compass is placed inside this circuit. Okay, let us see what happens. See, we know that when the key is closer, at that time some current flows through, current starts flowing in the circuit, right? Key close ಆದಾಗ ಏನಾಗುತ್ತೆ, circuit is considered as completed. At that time the some amount of current starts flowing in the circuit. Okay, the current direction is from positive to negative. That's why the direction is like this. Okay, observe this carefully. When the current is start flowing in the circuit, this circuit is made up of conductors, right? Now the current is starts flowing in the conductors. At that time, what happens? We know that some fluctuations or some deflections occur in this compass, right? Okay. Now, see here, the positive terminal is here and the current direction is here, like this. So that time, this compass is showing some deflection. Okay, first time initially it is in south and north. Starting ಅಲ್ಲಿ ಏನಾಗಿದೆ ಕಂಪಾಸ್ ನೀಡಲು ಸೌತ್ ಮತ್ತೆ ನಾರ್ತ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಇತ್ತು. When the current is flowing in this conductor, what happens? Some deflection occurs this compass. ಹೌದಾ, ಡಿಫ್ಲೆಕ್ಷನ್ occur ಆಗುತ್ತೆ. That time the deflection is towards east. Okay, so north south ಅಲ್ಲಿ ಇರೋದು ಏನಾಗುತ್ತೆ ಡಿಫ್ಲೆಕ್ಷನ್ ಈಸ್ಟ್ ಅಲ್ಲಿ ಡಿಫ್ಲೆಕ್ಟ್ ಆಗಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ, ಈಸ್ಟ್ ಡೈರೆಕ್ಷನ್. ಓಕೆ, ವಿ ನೋ ದಟ್ ದಿಸ್ ಈಸ್ ನಾರ್ತ್, ಸೌತ್, ಈಸ್ಟ್ ಅಂಡ್ ವೆಸ್ಟ್. ಇನಿಷಿಯಲಿ ಇಟ್ ಈಸ್ ಇನ್ compass needle is in north and south. When the current start flowing in the conductor, what happens? It gets start deflection, right? So finally it shows the east direction. Okay, east ಅಲ್ಲಿ ಏನಾಗಿದೆ ಡೈರೆಕ್ಷನ್ ಅನ್ನು ತೋರಿಸ್ತಾ ಇದೆ. ಜಸ್ಟ್ ರಿಮೆಂಬರ್ ಇಟ್ ಗೆಟ್ ಸ್ಟಾರ್ಟ್ ಡಿಫ್ಲೆಕ್ಟಿಂಗ್. ಇಲ್ಲಿ ಯಾವ ಡೈರೆಕ್ಷನ್ ಅನ್ನೋಗಿಂತ ಡಿಫ್ಲೆಕ್ಷನ್ ತೋರಿಸ್ತಾ ಇದೆ ಅಂದ್ರೆ ಅರ್ಥ ಏನು? ಹಿಯರ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಈಸ್ ಜನರೇಟೆಡ್ ವೆನ್ ದ ಕರೆಂಟ್ ಈಸ್ ಫ್ಲೋಯಿಂಗ್ ಥ್ರೂ ಅ ಕಂಡಕ್ಟರ್. ದಟ್ ಈಸ್ ದ ಮೀನಿಂಗ್. ಓಕೆ, ದಿಸ್ ಇಸ್ ದಿ ಫಸ್ಟ್. ಸೊ observe this one. Here we consider same circuit but one is different. What? this time the direction changes. This time the flow of current direction changes, right? Observe this. This is like this. Okay. This is from here to here, but this time it is in upward direction, right? This time the circuit is same, but the connection of battery is replaced or it is reversed. Okay, ಇಲ್ಲಿ ಏನ್ ಮಾಡಿದಾವೆ, ಬ್ಯಾಟರಿಯಲ್ಲಿ ರಿವರ್ಸ್ ಕನೆಕ್ಷನ್ ಅನ್ನ ಮಾಡಿದಾವೆ. ಆಗ ಕರೆಂಟ್ ಫ್ಲೋ ಕೂಡ ಏನಾಗುತ್ತೆ, ರಿವರ್ಸ್ ಆಗುತ್ತೆ ಅಲ್ವಾ. ಓಕೆ, ಲೆಟ್ us consider. Startingly again here the compass shows that direction is from north to south. Okay, when the plug key is closed, then the circuit is completed. Then again here the current flow starts through in the conductor. Current ಏನಾಗ್ತಾ ಇದೆ, ಈಗ ಫ್ಲೋ ಆಗ್ತಾ ಇದೆ ಇಲ್ಲಿ ಕಂಡಕ್ಟರ್ಸ್ ಅಲ್ಲಿ, ಆಯ್ತಾ. That time what happens, this time the deflection of compass again shows some deflections, right? ಈಗಲೂ ಕೂಡ ಏನಾಗಬೇಕಾಯ್ತು, ಇಲ್ಲಿ ಕೆಲವೊಂದು ಡಿಫ್ಲೆಕ್ಷನ್ ಶೋ ಆಗಬೇಕಾಯ್ತು, right? Okay, again it shows some deflection, but this time it shows different direction, that is west. Okay, see, first time it shows deflection regarding east. Okay, east direction, but this time it shows west. Means what? When the connection changes, when the direction of current changes, still the magnetic effect direction is also changed. Okay, see, we know that when the current is flowing through the circuit, when the current is flow through the conductor, it must generate magnetic effect, right? Yes, that is proved by Oersted, right? That is proved by Hans Oersted. See here what happens, he again proved that when the direction of current changes, that time magnetic effect direction is also changed. Okay, so magnetic field direction is also changed when the current direction changes. When the current direction changes, magnetic field direction is also changed. This is the important concept. So you should remember two things here. First thing, when the current flows through the circuit, when the current flows through the circuit, here flows through the conductor. Circuit is nothing but circuit containing conductors, right? Okay, so when current flows through the circuit, some magnetic field is generated in the circuit. This is the first concept which is invented by, or this is found out by the famous scientist Hans Oersted. Okay, then what are the second concept? It's also very, very important in circuit. When the flow of direction of current changes, that time magnetic field direction is also changed. Okay, magnetic field generation, magnetic field direction is also changed. This is also one of the important concepts. So these two concepts are very, very important. So students, in our today's class, we just learned some concept related to magnetic effects, right? From the beginning to now. What are those concepts? Just analyze those concepts once, and I will end my today's session. Okay, first we know that how what are the effects generated in circuit when the current flows through the circuit. Mainly three effects, that is heating effect and chemical effect and magnetic effect. Next come to the main concept, that is magnetic effect. What is magnetic effect and how it is generated and all we learned in our today's class, right? Okay, what is magnetic field? Magnetic field is nothing but it is one particular region where the magnet feels some attraction or repulsion. That is called magnetic field. Due to this magnetic field, some magnetic field lines are generated. That what is magnetic field lines? It is an imaginary line formed in a magnetic field around the magnet. That is called magnetic field lines. And then next we studied about what is the properties of magnetic field lines and all, right? Next we just discuss the concept about magnetic field or magnetic effect generated due to the current carrying conductor also. Mainly we can see two things here, right? One is when the current flows through the circuit, magnetic effect is generated. And second thing, when the direction of current in the conductor, or when the direction of current flows through the conductor changes, then that time magnetic effect direction is also changed. That is the another concept. Okay, students, we will meet our next session with the next more concept related to this chapter. Okay, then bye and take care.